Chapter 7.
States of matter. Matter.
Any substance that has mass and occupies space is called matter.
The space taken up by the matter is called its volume. All matter is made up of extremely small particles which we cannot see. These particles are called molecules. Molecule can be defined as the smallest part of a substance that has all the properties of the substance. So we can say that each sugar particle will have the properties of sugar. Matter and particles. Any substance that has mass and occupies space is called matter. The space taken up by the matter is called its volume. All matter is made up of extremely small particles which we cannot see. In most matter, these particles are called particles. A particle can be defined as the smallest part of a substance that has all the properties of the substance. So we can say that each sugar particle will have the properties of sugar. The arrangement of particles or molecules and their movement gives each state of matter its distinct properties. Table 4.1 shows the particle arrangement and movement in solid, liquid and gaseous substances. Solids, liquids, gases. Arrangement of particles. The particles are close together and arranged in a regular pattern. Examples: wood, stone, pencil, computer. The particles are less closely packed and arranged randomly. Examples: water, juice, milk, oil. The particles are far apart and have a very random arrangement. Examples: oxygen, carbon dioxide, nitrogen. Movement of particles. Vibrate about a fixed position. Move around each other. Move quickly and in all directions. Particles. Hard and rigid, they have a definite shape and volume. They cannot flow and cannot be compressed. They flow and take the shapes of the containers in which they are poured. Though they have a definite volume, they do not have a definite shape. Liquids can be compressed a little. They neither have a definite shape nor a definite volume. They are highly compressible. Why? The particles are very close to each other. They attract each other strongly and cannot move away. The particles are less closely packed than those in solids. The attraction between the particles is lesser and they can move around each other. The particles are very loosely packed. The force of attraction between them is very weak and they are free to move around in every direction.
Changing states of matter. Matter can change from one state to another by heating or cooling. The most common example of this is water. Take out a tray of ice cubes from the freezer. Ice cubes are water in its solid state. Leave it outside for some time. The ice cubes will melt to form the liquid state of water. On heating this water in an open pan, we will notice the water changing to vapor and vanishing into the air. It is the heat transfer in matter that causes change of state. Understand the phenomena of changing states of matter with reference to heat transfer and the movement of particles here. Melting. The change of a solid substance into its liquid state is known as melting. Solid ice melts into liquid water when it is kept in a warm place.
The particles of the ice take up heat from the surrounding and start vibrating faster. This breaks the rigid pattern of the particle arrangement and they start moving freely around each other. Thus, solid ice melts to form liquid.
Freezing. The change of a liquid substance into its solid state is called freezing. Water freezes into solid ice when kept in the freezer. The particles of water lose heat and their movement. Eventually, the particles come closer and become tightly packed. Thus, it takes the form of rigid ice. Vaporization. Vaporization is the change of a liquid substance into its gaseous form. Liquid water turns into vapor when heated in a container. The movement of the particles of the liquid becomes extremely fast on heating, and they move far apart from each other, turning into gas. Condensation. Condensation is the change of a gas into its liquid form. We see water droplets on the outer surface of a glass with cold water or ice in it. Water vapor in the air near the glass cools down. When it comes in contact with the cold glass, the cool molecules become slow and come closer to each other. As a result, tiny water droplets appear on the glass surface. Expansion and contraction. When we heat a substance, its particles gain energy and start moving away from each other. This is called expansion. Example: when it is difficult to open a bottle of jam with a metal lid, the lid is heated gently. The metal lid then expands and loosens its grip on the bottle and can be opened easily. Gases show maximum expansion, whereas solids show minimum expansion. When we cool a substance, its particles come closer and occupy less space. The substance contracts or shrinks.
The phenomena is called contraction. Example: if we keep an empty mineral water bottle in the freezer for an hour, we will find that it shrinks in and gets deformed. This happens due to contraction of air inside the bottle. When the air gets cooled, the air particles come closer and occupy less space. As a result, the bottle gets squeezed.
Reversible and irreversible change. The properties of a material can be changed. Some changes are irreversible while some are reversible. A change is called irreversible if it cannot be changed back again. For example, we cannot change a cake back into its ingredients again. So, we can say that irreversible changes are permanent. They cannot be reversed. New materials are always formed in an irreversible change. Many times these new materials are useful to us. Heating can cause an irreversible change. For example, we heat a raw egg to cook it. The cooked egg cannot be changed back to a raw egg again. Burning is an example of an irreversible change. When we burn wood, we get ash and smoke. We cannot change the ash and smoke to wood again. A reversible change is a change that can be undone or reversed. It is temporary. It might change how a material looks or feels, but it doesn't create new materials. Melting is an example of a reversible change. For example, melted chocolate can be changed back into solid chocolate by cooling. Freezing is a reversible change. For example, we can freeze orange juice to make ice lollies. The ice lollies can be changed back into orange juice by keeping them out of the freezer. Boiling, evaporating, and condensing are all examples of reversible changes. For example, if we could capture all the steam that is made when a kettle boils, we could turn it back to water by cooling it. How do some solids and gases dissolve in water? A solvent is a liquid that dissolves substances. The substance that dissolves is called the solute. The mixture formed by a solvent and solute is called a solution. The components of a solution get mixed together completely. Substances that can dissolve in a particular solvent are referred to as soluble substances. Substances that cannot dissolve in a particular solvent are called insoluble substances. Some solids that dissolve in water are salt, sugar, and coffee.
When a solid dissolves in a liquid, the particles of the solid take up the empty spaces between the particles of the liquid.
Two things that affect the speed at which the solid dissolves are temperature and the size of the grains of the solid. Sugar, which is made of fine particles, will dissolve quickly, but bigger sugar particles will take longer. Solids usually dissolve faster and better in hot water.
This is because in hot water, the particles of water move away from each other, creating more space between them. Oxygen, nitrogen, and carbon dioxide are some gases that can dissolve in water. Marine animals breathe in the oxygen dissolved in water.